Substitution rule. I am going to refer to it as U substitution. I can't help it. I always do. It's undoing the chain rule. Things that you differentiated by using the chain rule, you integrate by using U substitution. So again, we're going to have inside and outside functions. So if you have something that looks like the integral of 2x times the square root of 1 plus x squared, you want to identify your inside function, and we name it u. So u is equal to 1 plus x squared. Then the derivative, or differential of u, is the derivative of 1 plus x squared, 2x, dx. And then we're going to substitute back in, and we'll be integrating with respect to u, and then we'll substitute our x's back in. So step number 1 will be to find our inside function. This just all explains why it works. This is why it works. This is what you do. You let u be equal to your inside function, then the integral of f of g of x times g primed of x dx is equal to the integral of f of u du, and then you'll bring your x back. Examples will help it to make more sense. So, integral of x cubed cosine of x to the 4th plus 2 dx. So my inside function, again, just like when we were doing the chain rule, if there's something that has parentheses around it and it's inside those parentheses, that's a good first choice. It may not be the right choice, but it's a good try. So let's see. If we let u be equal to x to the 4th plus 2, then du is equal to 4x cubed times dx. What I'm going to do now is to isolate my dx. So I'm going to divide both sides by 4x cubed. So step number 1 was to select u. Step number 2 was to isolate dx. Step number 3 is to go back and substitute. So x cubed is still there. Cosine, instead of x to the 4th plus 2, I'm going to write u. And instead of dx, I'm going to write du over 4x cubed. So next step was substitute. U dx. So we substitute whatever we called u, and then we substituted what we calculated as dx. So we replace it with the du. Now, magic happens because the x's poof, disappear. So if the magic doesn't happen, then we go back and try a different u. Now I just have the integral of cosine of u, and I have du over 4. But that's just the same thing as a constant multiple. So it's 1/4 times the integral of cosine of u. And the integral of cosine of sine Don't forget to add C. And then we bring our X back. You can always take the derivative of that and make sure that you did it right. So let's finish what we started. Our step number 1 was to select u. Step number 2 was to isolate the dx. Step number 3 was to substitute. Step number 4 was to cancel stuff. Hopefully magic will happen. Step number 5 is to integrate with respect to u. WRT, with respect to u. And number 6 is to bring x back. There. It's great to have a game plan, isn't it? So let's do another one using our game plan. So example 2. Integral of square root of 2x plus 1 dx. Now remember, you could write that as 2x plus 1 in a big set of parentheses raised to the 1/2 power. So I'm going to let u be equal to 2x plus 1. Then du is equal to 2 dx. Isolate dx. Replace 2x plus 1 with u. So I'm going to write that as u to the 1/2 power. And then replace dx with a du over 2. Didn't even need any magic. I didn't get to cancel stuff, but that's okay, because I have something I know how to take the antiderivative or integral of. I'm going to go ahead and pull my 1/2 out front. Then I'm going to add 1 to the exponent and divide by the new exponent. And I won't forget to add c because I don't want to lose any points. So this is 1/2. This flips upside down times 2/3. And instead of u, I'm going to write 2x plus 1 to the 3/2. You could cancel that with that. Good enough. You could write this on top of 3. Lots of different things you could do to simplify, but there's your answer. And again, if you want to be sure you get them all right, take the derivative, and you'll come out with the square root of 2x plus 1. So while I'm writing it down, you are deciding, what do you think u should be? And chances are you said, well, it should be the thing under the radical, because if we have a radical, we pretty much always choose the thing under the radical. Good choice. So the derivative of that is minus 8x dx. Get dx all by itself. Now, if you've learned integrals before, use substitution, and you don't want to do it this way, that's okay. I won't judge you. You don't have to isolate the dx. You can manipulate it however you want to. I just find this a really easy and convenient way to make sure I get the right constant sitting out there. So I'm going to replace 1 minus 4x squared with u, and I'm going to replace dx with du over negative 8x. Yay, I get to cancel stuff, my favorite thing to do. So now I'm left with a negative 1/8, which I'm going to just pull out in front because it's just a number. U to the minus 1/2 power du. Negative 1/8, add 1 to the exponent, divide by the new exponent, add my constant. I can flip that upside down, and I replace u with 2x plus 1. Oop, 1 minus 4x squared. I looked up too high. You got the wrong u. 1 minus 4x squared to the 1/2 plus a constant. And of course, you could replace this with negative 1/4 instead of 2 over 8. More examples. Example 4, this looks a little different. We have an exponential. There's no big set of parentheses. But remember, when we took derivative of e raised to something, it was e raised to something times the derivative of the something. So let's let u be equal to the exponent function. Oops. U is 5x, du is 5 dx over 5, go away. So I have e to the u, I have du over 5, and antiderivative of e to the u is e to the u, so 1/5 e to the u plus my constant, which I refuse to forget. I try not to forget. Bring that x back. Easy enough. Now this one you've probably memorized anyway, because when you took the derivative of e raised to a number times x, you got e raised to the number times x times the number. And when you take the integral, you get e to the number times x divided by the number because they're opposites.